like to implore you that you should subscribe, like, follow, and leave comments, because the more people subscribe, the more this content gets pushed out to more viewers. Those viewers usually join, post their tips and tricks, or they can post their requests, which I'll personally review and I'll share with everyone. Especially with the AI, most of this stuff was requested by viewers just like you. So now on to the show. I should have an intro, and the intro says no more subscriptions. And like yesterday, I'm gonna make sure that I actually take it off, so that there's no overlay going on. All right, so stop relying on restrictive cloud subscriptions and slow web interfaces for your creative AI generation needs today. Most users are trapped in GUI bottlenecks that throttle the true power of their high-end enthusiast hardware. And sometimes it's not even, for example, mine is probably considered mid-range, but I've noticed that when I go to the command line, I can get way better performance. The only exception is probably ComfUI. ComfUI had really smart way of doing things on low end and less spec hardware, but most of the others they have way too many resource needs. You can bypass every limitation by moving your entire production workflow into a dedicated Python virtual environment. This transition unlocks direct access to your VRAM and allows for precise control over every generation parameter. So if you guys, when you go to like Hugging Face and you see all those models and you can never use them, you have to get specific models, either GGUFs or something else. Well, in today's tutorial, I'm going to show you, so this is like a masterclass. I'm going to explain what all that stuff means and how to get it up and running. It's actually much simpler than you think. Okay, so for the local intelligence experience, imagine the thrill of watching a high-definition video render locally using nothing but raw code and optimization. So the initial setup feels like a complex puzzle until the first frame appears on your high-resolution monitor. Your fans spin up as for example, I have an AMD Instinct MI60. So your billions of parameters create fluid cinematic motion. The level of detail sovereignty provides a creative edge that no standard consumer software can ever match. And optimizing the generation pipeline, this transition from bloated graphic interfaces to lean Python script reduces your system overhead by several gigabytes. Now, if you guys know, I like Python, but man, all this AI stuff, you just have to get so many wheels and stuff, and then you have a lot of stuff. I mean, especially if you try different things, you have so much stuff going on. And then one thing I really dislike, I love Hugging Face, but one thing I really dislike is a lot of these tools to automatically grab stuff from Hugging Face, and then you have like duplicate, even though there's supposed to be only one Hugging Face folder, and I'm saying like they don't give you an option to download the stuff yourself, because some people tell me, oh, it's okay because Hugging Face has parallel download. That's true, but I also have parallel downloads, and my parallel download, I can actually fine tune it to, for example, use all my cores, all my threads, or just, you know what I mean? So I'm saying is that I like the fine-tune control. If I'm going to be on the command line, why can't I fine-tune control it anyway, right? So using a virtual environment ensures your system remains clean while you experiment with the latest cutting-edge libraries. This approach represents the pinnacle of modern digital craftsmanship for those who demand absolute performance. Not only that, maybe you want to train some models, or you want to train LoRa's or something like that. Obviously, if you understand the things going on, you can fine-tune it for your needs, not taking something that somebody else trained and then try to get it to work, for your needs, right? So you can just basically just train it for your specific needs. I'll give you an example of this. The Z Image Turbo that was released last year, and then I believe it was this year they released the base model. So what I'm trying to say is that even the Turbo, it was trained on some generic stuff. It works fine even for my particular use case, but there's somewhere I would love to fine tune it. So obviously now I can get the base model and train it to exactly what I need, because you guys know what I need. I don't need I don't need like humans. I need like claymation characters. So For me, that would be absolutely perfect if I could get it to do that. So as you can see here, I have an example on the left here, this screenshot. I have the Z image turbo, and then on the right here, this is WAN 2.1 1.3b, and I'll explain to you why I chose those two instead of getting others. So as I said before, I have an AMD if you have AMD hardware, you prioritize HIP plus. Obviously, if you have NVIDIA, you have CUDAs. And the good thing is, especially if you have NVIDIA one, is that a lot of AI stuff has been really almost hard-coded to NVIDIA stuff. So you guys have it much more easier than literally everybody else. And of course, you can also, if you just have the CPU, again, especially now, there's been a lot of stuff going on with Vulkan and stuff. You might actually find that, especially if you have a powerful CPU or a lot of cores, you'll be able to do that as well. I've done tutorials on Vulkan, so if you want me to do more, let me know. Put that in the description. Okay, so because my GPU is no longer officially supported, I have to put this override 906. So this allows libraries to be able to detect it and still use it, because the drivers, everything still works perfectly fine. So this specific configuration allows your system to treat the professional accelerator as the native high-performance computing device. You notice an immediate jump in token per second once the memory mapping is correctly aligned. So for example, if you use GGUF images, which you can, and I'll show you how to do that as well, you can use this processing engine, the Llama CPP, and then if you, for the 1.2.1, you can do 1.2.1 text to video or 1.2.2 image to video. So you see it uses quite a bit of RAM. Now you might say, oh, that's not a big deal. Well, for me it's a big deal, because if you guys remember, I only have 32 gigs of RAM, and because I have an integrated graphics, 4 gigs of that is reserved, so it's down to 28. But then I use like the normal desktop. For example, right now I'm using OBS, I have a bunch of browser windows open. So basically what I really have is about 21 to 22 gigs free. So clearly that's not enough. You can see this would not be enough. So what I do is I use something called ZRAM, which compresses the RAM, and I prioritize it so that it doesn't go to the swap file. So that's what I do. Unfortunately, in Linux, unlike Windows, the swap file doesn't dynamically increase and decrease. So that hits my. Remember I said I have limited storage as well. It's not just the memory. So I'm stuck in a terrible place. Okay, so now I think before I do anything else, I'm gonna segue into, let me make sure here. Oh wow, there's a lot of stuff I downloaded. Okay, I'll show you all this stuff. I'll show you everything here. You can I'll show you a better way of getting this up and running. So this tutorial is technical, so I'm going to go a little bit quickly over some of the stuff. So but first let me segue. So as you guys know, I have idealum.space, idealum.store. This is where I'm going to be putting my my books, so that it'll be easier to find them in one place. I didn't have a dedicated domain for it, so I'm going to use idealum.store. So for my books, so for example, I have this algorithmic surfing. I'll talk about it later. It's a novelette. If you're interested in psychological thrillers, you can pick this up. It's on Amazon right now. It's very affordable. I'll talk about that as well later. And then my latest one is this one, the Recession Business Blueprint. This is a real book. So I mean, it has over 130 pages. That's excluding the table of content and all the other stuff. So you get a real 130 pages. So this helps you start a business during a recession. I'll talk about this later as well. And then this temp mail service, I'm still thinking of a name. I've changed my mind again. So I will. I think I'll just leave it as that. Maybe temp mail service or 5 minute mail service. So I'm gonna leave this. I'm gonna tweak it a little bit, and this should be up and running. I mean, it is up and running now. You can use it, but I think I'll tweak it for tonight or tomorrow, then I'll officially launch it sometime this week. So be aware of that. That will be officially launched. And then ojamboshop.com also will be officially launched. I'm hoping sometime within the next 4 or 5 days. You can take a preview of it right now. Okay, so what I'm going to do is, so I'm going to show you a few places, and so normally if you get the GGUF models, I have a tutorial on GGUF. If you don't understand what that means, it's basically when models are released, they usually are released as FP floating point 16 models. So the researchers, obviously they have like powerful systems, they have GPUs. So that the good thing is they do release the models. So the problem is for consumers like you and me, people watching now, we do not have the same access to those type of GPUs. We don't have like a room full of GPUs. You just have, your tower, a mini tower. You have maybe one GPU, you might have two. And so what I'm saying is we're limited with even RAM. We're limited on our consumer grade workstations. We're limited with RAM, and we're limited with the GPU VRAMs as well. So when they release those models, they don't really care about what I'm saying is that they make some assumptions, which is just fine. At least they're releasing the model. I'm just saying that they're still too big for us. So I gave you an example of my particular system. Yes, I do have a 32 gig VRAM GPU, but I only have, as I said, only about 22 gigabytes of RAM. You know what I mean? So so when you release a FP16 model that says 60 gigs, I can't run, right? So that's what I'm saying. So that's why GGUF exists. I said I did a tutorial. So you can go to ojambo.com and search for GGUF, or any of the channels you're watching right now. If you search for GGUF, you might be able to see it as well. By the way, I want to thank the people who from the podcast as well, the Tech Rants. Welcome. Thanks. Okay, so you see the GGUF. So the GGUF here, you see this 8-bit, and you see, for example, this one is 7.2. So that will easily fit on my system, both the RAM and the GPU, and of course the 6-bit, 5-bit, 4-bit. I don't recommend going below 4-bit, but if you're really desperate or you're running on your CPU, then you can go 2-bit. Like this model is actually pretty decent even at 3-bit. So this one you can definitely get that one. Now, if we go and read some of the stuff here, you see to tell you where the model, where the original. See, it says it quantized GGUF versions of the Z image turbo. We'll go there in a second. By Tonyi Mai. Hope I said that right. So as you can see here, the credits and everything as well. So so you can see, obviously you can talk here, but we're going to go to the original model here. You see, here's the original model, okay? So it explains the papers and all this stuff. So what I was trying to say is that you see all this information. They will probably give you some snippet as well to show you how to run this model. So that's what we're going to do today. So as you can see here, they usually have some snippet code. They have examples. You can read all this stuff, but yeah, here we go. You see this? So they give you instructions how to run this. Now you see, they don't tell you, oh, run it in config, run it stable-diffusion.cpp. No, they actually give you instructions. For example, they tell you to install Git and then all this stuff here, to get it. So you can download them manually. I tried that. I was actually pretty dumb of me to do that, but I actually did download each of this stuff manually. Ooh, boy, that was stupid. Let me tell you, don't do that. It's going to take you a very long time to do that. Just do a Git clone. Trust me on that. There's so many files and whatever you have to get. So do a Git clone. Do not. I repeat, do not. Do not do what I did. So as you can see here, then this is a sample Python script. It says import torch from diffusers, the Z image pipeline, and then you can see you can get all this stuff here, and You see it uses bfloat 16, which my GPU doesn't support, but it's good and close enough to floating point 16, which my GPU does support, so it'll be fine. And then you can use low CPU memory usage, set it to false, and then the pipe to CUDA. Now, here, this is the thing that used to confuse me before. I remember I told you earlier that NVIDIA was basically the only game in town. So a lot of people just hard-coded NVIDIA names to it, for example, like CUDA. Now, so if you have like an AMD GPU, you cannot simply just type in AMD or ROCm or whatever. You still have to use CUDA. CUDA has become synonymous with the word GPU or a dedicated GPU, is what I'm saying. So even if you have an Intel one, you still have to put the word CUDA there. Okay, even if you have an integrated graphic, you still have to put CUDA there. That's what I'm saying. That's how basically what I'm trying to say is that AMD finally started taking this stuff seriously very recently. Obviously, Intel was very late to the dedicated GPU game, so that's what I'm saying. That's why it was CUDA like that. And then you can see the prompt in the image, and then you save the image. So this is exactly what we're going to do. Almost word for word, exactly what we're going to do. And I'm sure you guys have noticed by now, we're basically going to do the same thing for the WAN model. So I'll show you that one next. So for this one, there was so much stuff I had. You see, I have to get all this stuff. I had to get the schedule. I think I had to get the scheduler, the text encoder, the tokenizer, transformer. That's what I said. Like, do not do what I did. Just do a git clone and the VAE, and you see here. And then you also have to have a middle. Most of these folders also have some type of JSON. For example, if you go to transformers, you see it has a config.json. And if you go to the tokenizer, you see it also has a couple of JSON files. So that's what I'm saying. I was downloading this one by one. That was a pain in the butt. That's what I'm saying. Telling you, just do a git clone. You set your mind at ease if you do that. If you don't, yeah, be prepared to wait for a while. Okay, so I'm using the 2.1 text to video 1.3B model. If you have the resources, more RAM, go for the 2.2 or 2.1 14B. I'm going for the 1.3B because, as I explained, I don't have the RAM. Now, even though this model and the bigger models can probably fit in my VRAM, the problem I really dislike the way AI works is that it loads the stuff into RAM first, and then it sends it to the GPU. That drives me crazy because I'm thinking, what's the point of having a big GPU? Why don't you just put it right on the GPU? Why do you need to load it into RAM? Now, I think I understand why they do that, because this is meant for, as I said, consumer grade stuff. So they assume, which was perfectly legitimate, I think for like 99.999%, probably 100% except for me, is that people usually have more RAM than VRAM. So that makes sense. But I'm the one where I actually have more VRAM than RAM. So I'm like complete. I'm like I'm really out there, the only one. So obviously I said I'd like to have more RAM, then I wouldn't be complaining. But still, it's something. Yeah. So here we go. This is the 2.1. The model has been around for, I think it's now 2 years, maybe a little bit more than 2 years. Yeah, so as you can see here, this is what I was trying to tell you. Do not, I mean, you can, but I'm saying is, I'm telling you again, do not do what I did. Clone it. Do a clone. You'll thank me for it. Do a clone. There's a lot of little files, and then after that, you can create a virtual environment, and then just install everything. So as you guys know, I don't have enough storage space, so what I do is I use the system-wide, meaning I install all these packages for my Fedora repository, and then I use them system-wide. Now there's good benefits there. The good benefit is that they take up a total of 2 gigs, so meaning that I can use them across multiple, as you'll see, I can have multiple virtual environments and it won't be a problem. Now if I had obviously space, I would each of them would be, and I'll get all the Python mules that way instead. And then, so the good thing about also running Fedora, and I guess OpenSUSE, because OpenSUSE and Fedora, they do co-manage the, the ROCm, all those AI stuff. So the great thing is, the packages are pretty up to date, so I don't have to worry about this stuff like this. So, and then you can see here, the model we're going to use is this one, the text to video 1.3b. Now you can get this model to do image to video as well. I've shown you some workflows that I did, ComfyUI and etc. And also I tried it, which I did successfully, sable-diffusion.cpp, but overall it was meant for only text to video, and that's what we're going to do today. So they recommend downloading the models using pipe install this and install this as well. So you don't have to do that because the Python code I'll show you will do that for you. So that's why I was trying to say, like, I wanted to get this tutorial out of the way, not because I'm excited, it's also because it's taking up a lot of space, storage space right now. So I want the story to be done and we can finish it as quickly as possible. So as you can see here, the text to video, the 1.3b model, it's trained at 480p, right? It cannot do 720p. Well, yes, it cannot do that, but you can always, if you get really good code, you can then upscale it later. All right, so yeah, there we go. And then you can see they show you examples again, how to, if you do that, how to run it. And here's some sample. Remember I told you all these ones, they show you some sample code. So in this case, you can see the sample code here. You just follow these instructions and you'll be good to go. So this here is considered 480p. So I'm pretty much fine with this one, and you see I'll put the video, and just, as I said, just literally just follow these instructions. That's literally all you need to know. I said I'm gonna do it with a simple twist, where I'll show you the code I have and everything else. All right, so you don't have to download anything. You can download all this stuff for you. But as I said before, I highly recommend do a git clone. Don't do what I did. All right, so now. Obviously, if you need some other stuff, as you can follow these instructions here. This is the entire paper, or at least the summary. You can go read all of that stuff on Hugging Face. Okay, now let's get started here. I've explained what my system specs are. One more time, we'll just quick overview here. I have a Ryzen 5 5600 GT, so it has 6 cores and 12 threads, as you can see all the 12 threads here, and I only have 32 gigs of RAM, as I said before. And because it's a GT, the G stands for integrated graphics, which reserves 4 gigs of my RAM, so I left to 28 gigs, as you can see here. Then I said I'm running things like OBS. I have a multi-streaming, by the way, and so there's a bunch of stuff going on. So really, the usable RAM I have is most likely 20-ish something as well. I don't know what's using so much RAM right now. I'm guessing this is gonna be a race condition. I'm looking at OBS for that. yeah, I don't think I'm running anything else because that is a little bit high. But anywho, and I said so. I also use ZRAM. So ZRAM takes 16 gigs of that remaining 20 whatever. And so they'll be compressed, and then, as I've said before, I prioritize it. So I have a 24 gig of swap file. You can see this one here, swap file. You see it's 24 gigs. So that one as a last resort. I don't want it to go to that one. So hopefully everything stays in ZRAM at least. Okay, now and you see this is the folder where I downloaded all these files manually. I literally downloaded all this manually. That was really not smart. That wasn't smart. Like I said, if you're going to do this, do not do that. Do a git clone. Okay, so, and then yes, so where did I put the files? Give me a second here. I don't remember where I put the files. Did I delete the files? Oh, I'm using GGUF for the Z image turbo. So I'll show you how to do that. That's why I was wondering. So I'm using, as you know, I use ComfyUI. So ComfyUI here, we go to the usual ComfyUI, where is models, And if we go to unit, you see I already have the Z image turbo, this one Q8. I think this one might be a little bit big. Oh, we have the Q4. I think this I can use this one as well. So I'll be using one of them, and I'll show you how to get all that stuff. So Amit Palalandan, I hope I said that right. Hello, thanks for joining the live chat. By the way, if you join the live chat, you it will show up here, as you can see. Just found a user. Thanks for joining the live chat. Alright, so let's get started here. I'll go back to the main AI folder here. You don't need to see this. And if you guys don't understand, I don't use this anymore. In fact, I'm actually going to get rid of it today. I don't need that one anymore. The control. It's because I now use my own fan profile. You see the scripts. I finally got the systemd working, so it will ramp up and down as needed. Alright, yeah, I'm sure you can hear it a little bit because I set it to 1%, and then it will ramp up up and down. So I think that should be fine. Okay, so so you can, what is it here? Whoa. Right here. Alright, so as I said before, let's get started. So here I want to make sure I didn't mess up. I might have made a folder. Let me make sure I didn't make a folder here for Z image turbo. I might have made a folder for Z image turbo. Z image, did I put code in here? No, that's not it. What is, no, that's testing. Yeah, so I did not make a folder. I just wanted to make sure. Okay, so yeah, I did not make a folder. Perfect. All right, so let's, as I said before, let's get started. So make sure you download the stuff. I said I really recommend use the git clone or use the Z, whatever, the Z. I think that's the one for Hugging Face, or whatever you do, parallel, and get going. All right, so what I'm going to do first is I'm going to, what's the code snippet we have here? Okay, so I'm going to do some command line stuff here. I know you guys don't like the command line, but bear with me here. Just want to show you that I have everything installed, and I'll prove that to you. So, show you that I do have ROCm installed. You see ROCm, and you see I have two GPUs. Obviously, one of them is clearly integrated graphics. The other one is the dedicated graphics. Now, let me zoom out just a little bit here. So the one that's 225 watts, that's clearly the dedicated graphics, and the one that's only using, what's the other one using? The other one that's using only 20 watts is clearly the integrated graphics. So in this particular case, we know which GPU, so this one, GPU1. GPU1 is clearly the integrated graphics, and this bad boy here, 0, is obviously the dedicated graphics. And then, you're going to see some info about the GPUs. So you're pasted here again. I get ROCm as well. So as you can see here, another way to find out which GPU is which. You see GPU 0 here again. It's 32 gigs, right? And then GPU1 is only 4 gigs. Remember that reserved RAM? That's where it's going here. Okay, and then of course, I also have Vulkan installed. If you guys are going to use Vulkan, I'll show you that as well. So just Vulkan info, and you can see here it detected 3 devices. The first one here we know, that's obviously the integrated graphics, and the Vega 20 is the dedicated graphics. So Vulkan has it backwards, and then LLVM pipe, this is for software rendering. I clearly don't want to use that one because that's a software emulation. Obviously that's going to be the slowest. So the one I want is to use this one, this priority, and then after that you can use the integrated one. I don't want to go to software. That's going to take forever. Okay, and then of course, now Vulkan is actually pretty good. So if you want to see what limits you can do on Vulkan, I'll show you here. I'm just going to grab a command in Vulkan info, and you can see here I can do stuff like this. You see it's float 16 integer 8, float 16 integer 8, float 16 integer 8. So that's what, now if you ever wondered why you can't run some things in Vulkan. This is why. Obviously, you're going to need specific things for your GPU. In my particular case, I already knew this. So that's fantastic. And then the capabilities. We're going to check the capabilities for Vulkan, if you can actually do AI. So you can see here, I'm looking for a matrix. Obviously, I already know my particular GPU does not support the matrix stuff, which is unfortunate. But I do know that it supports float 16, as you can see at integer 8. Matrix it doesn't, and compute. See, it has compute here. So this proves that my particular GPU, let me scroll up as well so you can see all the other stuff. You see dot, integer dots as well. So that's a good thing as well. Now you might see from float 32. Very few people use that these days, especially I don't think any consumer grade GPU will be able to run float 32 anyway. Just by itself. If you put them in parallel or something, maybe. So that's the information. And then here is one of the problems so far with my GPU. I think AMD, unless I'm wrong, I believe AMD hard-coded this. So I'll probably need to flash this GPU in order to make this bigger. So when I go to and find out how much the max memory allocation size, you see, unfortunately, it's right here. It tells me it's only, excuse me, I believe that's only about 2 gigs here. So I tried different ways to set it up. Increase it, I was not able to. So if you don't understand what this is, this means 2 gigs. So I was trying to set it up to 4 gigs at least, but mine is stuck at 2 gigs, even though I have 32 gigs of RAM. So hopefully we'll be able to do a workaround that, and that's what I'm saying. If I had more RAM, I probably would not care. Alright, so now let me get rid of this. Now you have to make sure that you have Python 3 installed on your system. As I said, I'm using what am I using? Now you might be wondering, why am I using llama -cpp? The reason I'm using llama -cpp is because it can load the model even if it's not a video or image model. It will load the model, and then it can pass the information over to other Python libraries. So that's why you're using it. So that's a trick to get the GGUF working. I learned that the hard way as well. So just make sure you install it. On my system, I'm in Fedora. It's already installed, by the way. So all you have to do is just go like this. You see, I just installed Python 3 llama cpp, so whatever your system is, Windows, Mac OS, etc. And then after that, to check to see if it's installed, you just use a Python. I'm just going to put a one-liner here. You see, -c, then import llama _cpp and print is installed. You see it's installed. Okay, so I installed it only for you guys. And you guys, if you remember last year, I did some tutorials where I was showing you how to build your own web UI for this llama -cp. I stopped that project because llama.cpp server comes with a web UI, so there's no need to do duplicate effort. Okay, and then so now let me see where I am. Yeah, here we go. So what I'm going to do is I'm going to create a let me make sure. Yeah, I'm going to create. So if you remember here, I don't have an environment. So I'm going to create an environment, and I'm going to install some stuff. Now I'm going to make sure I do it system-wide packages. Remember, see that you just saw that Python library that's installed on my system, right? So most of the tutorials, actually all the tutorials online except for mine, they'll tell you to install all the stuff inside the inside the virtual environment. Now that's fine if you have the storage space for it. I said I am limited with storage space. Just to prove to you guys I am limited with storage space, here I'm going to show you this right on the command line. So this is my main system here. You see I have only 10 gigs available. You see my point? I'm I'm using 95%. And then this is AI folder here. I'm already using 88%. And I said I had to delete some models like the LTX2 models. I had to delete some other stuff, and that's the reason, because I said I'm very limited with space. And I also use this folder, not just for that. I also use it for what do I use it for? I use it for Podman. The Podman containers stored here, and obviously the swap file as well. So like I said, I'm really limited in space. Now, some of you might be smart and say, hey, wait a minute. You have some other stuff here, but you have to remember, you might be looking at a mechanical disk, right? So do not, for example, this data one here, this one I could use some of this space, but I think this one is actually I believe this one is actually a mechanical disk, if I'm correct. I think this is a mechanical disk, so I can't use that one. But anyways, back to the show here. So I said I have limited storage space, limited RAM and limited storage space. So yeah, so I have to be careful what I'm able to do. Anywho, I'm in my mount folder here. The reason for that is because I said I already downloaded this manually. Again, do not do that. Do a git clone. All right. So what I'm going to do is I'm going to create a folder that we can actually work in. I'm going to call it AI project, and I'm going to cd into it. You see, I've created this one here. Where is it? AI project. I just created AI project, and I've now cd into it right here. Actually, you know what? I'm gonna keep this on top, always on top, so you can see what's going on. I'll put it down here so you do see what's going on. So then, what I'm gonna do is I'm gonna create a virtual environment. And you might say, wait a minute, you said you're not gonna do it. Yes, I'm gonna do it. But you see here, I put system-wide packages. You see that? System-wide packages. So what that's going to do is, system site packages. What that's going to do is it's going to use the packages that are installed on the system instead of like there will be less duplication. There will be. So remember, I said I'm very constrained with space. And then what I'm going to do is I'm going to type source space AI underscore environment / bin / activate. Okay, so it's been activated. Now, remember, I've just created this, so it's empty. However, I remember I told you I've already installed all this, like the torch and all that stuff, because they're system wide. The same thing I do with Comfy UI. So now, if I go here and I type in pip space list. Then I put the pipe symbol in there, then grep -e, and then I search for the word torch. You see, torch audio data, all this stuff, torch vision. Those are installed from the Fedora repositories. Okay, so meaning that I don't have to install. Now this is what I was trying to say. So it only takes up 2 gigs of space on my system. If I install this inside this virtual environment, Python virtual environment, it's going to install like it's 4 gigs. See my point? As I said, I'm very constrained for space. This will allow me to create multiple environments using the same. That's why I told you make sure you use system-wide system site package. Now, because I do AI stuff, almost every other day, I'm okay having them on my system, even though I complain about how big Python is. That's perfectly fine, because I say I can do stuff like this. And then to find out if it also detected inside this environment, which it should, it detected my, obviously rock M and all that stuff is on the system as I proved it, so I just type which space pip cc. You see that? So it's using the system packages, so I don't have to install this as well inside this environment. I'm going to use the system one. Alright, now I need to install some things which unfortunately are not in Fedora at the time of this recording, and I'll explain to you why I need to install all of this. So I'll just use the pip command. So I'm installing diffusers, I'm installing accelerate, I'm installing transformers, I'm installing GGUF and FTFY ImageU FFmpeg. So I need all of those packages to generate images, and you can see it installs this Hugging Face as Z. That's the one for the parallel download. Okay, so I get here and it's done. You see, it's very quick. You see, these are wheels. If you don't understand Python, these are wheels. You see that? Those are the wheels. See, these are pretty small files. That's why I'm able to do this, right? But you can imagine if I was having to if I had to install Torch, I know that'll take a very long time, and you have to get a specific version of Torch that's for the GPU. Then you have to install the GPU drivers and all that type of stuff. No, that's what I'm saying. I use system-wide to save space. Now you guys learned something. All right, now I'll show you what text encoders I'm going to use. Let me clear this down here. You see, I can tell I'm still inside the environment. I'll show you where the text encoders are, and I'll tell you which one we're going to use for the image generation. But you see here, I also have a quantized versions of the text encoders, right? So you see I have the Q8, I have the Q4 for the UT5, and then the Quen 3B. I have both the Q4 and I have the Q8 version. Two different versions. One is the instruct one and one is the UD version. Okay. Then the VAEs. This one is pretty easy. The VAEs, I can use this Pig Flux one, or I can use the yeah, I think that's the one I'm going to. No, the AE safe tensors. That's the one I'm going to use. And then for the one, I can use this one, the VAE safe tensors, or I can use this one here as a tiny encoder, a text encoder as well. But I think I'll just stick to the plain one because the model is small, relatively speaking. And then, as I showed you guys earlier, the what do you call it? The unit folder. So the unit folder here, I have all these models here. So I have the Q4 WAN 2.1 Q4 KM. I have the Q8 version, the very small models. Then the GGUF I'm talking about, and then I have the WAN 2.2. This is my daily driver, high noise, low noise. I just mostly use low noise now. And I also got this Rapid Mega. It's also the same thing. It's the 2.2 14B one. I'm just testing it to see which one will be faster. And obviously I have the Z Image Turbo, Q4 and Q8. Okay, so just download what you need. You can see that that's basically all the models I have right now. Now, if you remember that photo I showed you earlier, the one where I manually downloaded this stuff, not very smart. Again, I repeat, you do a git clone. Do not do what I did. That will take you forever. Oops, what name did I use for that one? Okay, this is the one here. I guess I changed the name, so let me check it out. Okay, there we go. So these are the models that I did download. Those are the models that those are all the weights that I did download. You can see here. You need a schedule. You see, I told you every folder has at least one JSON file, so you have to get all this stuff. So I downloaded this manually. I set this folder up manually. Not smart to do that. But I said, like, yeah, there you go. It does work, but yeah, don't do what I did. And this thing is pretty big too, right? You can let me show you how much. Let me tell you how much space it's taking up. That's why I said I'm eager to finish this quickly, so I can. You can see it's taking up 27 gigs. I really could use those 27 gigs quickly. So that's why I said I want this story to be done quickly, so I can wipe this as quickly as possible. All right. Now for the Z Image Turbo, I'm going to create a file, and you should see it in here. I'm going to pull this up here. Okay. So where are we again? AI project here. So you see, this is our environment. That's what I'm using right now. Now I'm going to create a since we're in the command line, I'm going to create a file to generate images using the Z Image Turbo. So I'm just going to use a cat command here. Okay, so the file has been created. Now let's go over this file. It's pretty straightforward. Okay, you know what? I think I'll use Nano. Since we're here, use Nano. Oops. Okay, so you guys can see a little bit better. So you can see the model path. I'm using the Q4 version, and you see this the VA path. It's gonna be the AE safe sensor I showed you there, and then the repo, I showed you this as well, for the Z image turbo, and you see it's the transformers, the pipe. This should be very familiar to you guys. It's the same. It's a little bit different than what you saw from the official repository. The official repository. The reason for that is because the official repository is using what do you call it? It's using the those safe tensors and all this. So what I'm doing is I'm using the GGUF model. That's why I said mine's going to be different. So you learn a lot. You probably didn't know you could actually. I mean, you guys probably know. I didn't know anyway. And you see, I made the size the way this 512 by 1024. The number of inference steps 4 because it's a turbo model. And the guys in scale, I set it to 0. That's the same thing as setting it to 1 in Comfy UI. And the output is going to output Z image turbo, output PNG. Let me scroll up here so you guys can see what's at the end here. Oops, down. It's the same thing. There's nothing special. See that? GGUF quantization config. Okay. And then here, just to make sure you can see, it's BF float 16. I tried putting on a floating point 16. It did not work. So the only thing that worked for my GP was BF 16. Float 16 did not work. It would give some weird results. So I just said, you know what? I'll just leave everything as B floats. So there we go. And down here, we're done. So I'm gonna exit out of here. There's no need to save. Now I'm gonna run this. So it's pretty simple. You know, just like when you're in Comfy, I just type Python main.py. In this case, I'm just gonna type Python. Yeah, I'm gonna actually put it here so you can see what's going on. Python space Z image. There we go. If you hear the whatever, the noise going up from the GPU, that means that it's actually passed the information onto the GPU. So the first time this runs, obviously it's slow. So I expect, because I also have something is taking up that 10 gigs. I'll show you the system monitor as well. Monitor. So you can see what's going on. There we go. Let's see if I can make this smaller. Where does it begin? Okay, so there we go. You can see what's going on here as well. As I said, one thing I dislike is it always loads the model into RAM first, then before it throws it onto the GPU. So it's doing some stuff here. Oh, it's beating more. Okay, I thought it would use something from the cache. So it's gonna fetch whatever it needs. You see down here it's downloading. So I'm guessing it's gonna download the. I couldn't get it to use some of the GGUF models. So if it can't, it just basically goes and downloads the file. So I was like, you know, that's perfectly fine for this tutorial. So I'll let this guy go. And you can see here it's going to download up to 8.22 gigabytes of space. So this one is fine, but I said for the 2.1, that one takes up quite more space. So that's why I wasn't comfortable. I said that's the one of the reasons I wanted to download the stuff. So I have it here for this tutorial. So let this guy go. It looks like it's going to be about, it doesn't say here. What is it? It's going to be a few minutes. So while that's running, I'll just keep on talking while that's running. So should you do this? Obviously, if you have a problem with some of the existing workflows, yes, because it's going to be tailored to your particular workstation instead of just being generic. Should be fine. That gives me time. I can actually go grab a drink of water. You know what? I'll be back. I'm gonna go grab a drink of water because it looks like the sun finally came out. after it was like really cold in the morning. Even the heater came on, which was weird. I set the heating I set to 13 degrees Celsius. And yeah, I have a funny story to tell you guys. So the cold season this is the longest cold season of my entire life. So October 15 it snowed, and it's been unrelentless since then. I remember October 12th. I was working in the shed outside, and I saw a chicken. She was standing on one leg. I'm like, it's October 12th. Why are you standing on one leg? And then I realized later, because October 15 was so cold, it snowed, and man, it's been cold since then. Anyways, what I was trying to say is that I did not switch on the heater until November 1st. November 1st, I set the heater to 16 degrees Celsius permanently. And then December, I dropped it to 15 degrees Celsius permanently. It actually got cold in December. In January, it got even colder still. You know what? I set it to 14 degrees Celsius. And then in February, I set it to 13 degrees. February was even colder. I set it 13 degrees permanently. And then I was thinking, with that trend, does that mean in March I should set it to 11 degrees? Or should I start going the other way? Or should I leave it? Should I go back to 14 and 15 again? So what I decided to do is I just left it. I guess I was a little bit lazy. I left it at 13, so it's been 13. And the other weird thing is, on October 15 as well, after I finished the live stream, I went in the hoop coop to pick up eggs and clean up the hoop coop. And it was just before 3 p.m., right? Like 2:50 p.m. And it was completely dark. I couldn't see anything. I just flew around, grabbed some eggs, and I went. It was completely dark, and it stayed like that until like January. I remember one time I was getting ready to prepare dinner. I was like, "Oh, it's 5 p.m. and it's still like there's still some sunlight and stuff outside." And then last month in February, 6 p.m. there was still some light outside, and now, way past 6, like 6:30, whatever, almost 7. There's already light outside now. The reason that's weird is because usually it's in winter that you have a short day, right? But this, I said, the weather just so weird last year. Like very cold winter, then a drought, and then another super cold season. So I'm hoping this year things will be back to normal, because I really want to get my fruit trees, and when those chickens arrive, replacement chickens. Oh, and also the car. I tried to start the car yesterday. It's not even cranking now, and so I think it might be the battery. So yeah, the battery is 8 years old. I confirmed it yesterday. The battery is just over 8 years old. I replaced the battery in it was February the 26th of 2018. So yeah, the battery is 8 years old. I think the battery is done. I think what killed it was the tire was flat. So I used the 12, was it 12 volt or whatever that is? Yeah, 12 volt, and I could see it struggling, but I just kept at it. And yeah, so I think it's the battery. I don't think it's the catalytic converter or bad gas, because the gas is like almost full. It's like at least 7/8 full, so I don't think bad gas will get in there. Yeah, and I was thinking about this when I was in Toronto. The car was underground all the time because I work from home. Even when I went to the mall or whatever, grocery shopping is always underground. And then when I moved here, I stayed in a hotel, but the hotel had an underground, so it was only when I went to the office. Stayed with my nieces for a little bit in the winter, but it wasn't that bad. And then the first winter here was mild, and then obviously the last 2 winters are pretty harsh. I think that's what finally did it, and the battery in. So this downloaded pretty quickly. So Z. So okay, so it found all the weights, and then what is it doing here now? Okay, so yeah, now it's running. It's not like that slow. I'm showing, obviously, the reason I did this was to show you how long it actually takes to download and all that as well, just to show you that because somebody yesterday was asking why I don't do some of these tutorials like pre-recorded. The reason I was telling them that is that when I do it live, if something goes wrong, I can fix it, and you guys can see how long it actually takes, right? I'm not making up. Obviously, I could cut that part out, like the download and whatever. I'm saying, like, it's a live stream, right? It's not meant to be. See, the model is pretty fast, as you saw. Look how fast that was, right? Now, if I run this again, it'll be even faster. I wasn't even paying attention to this. So you see, it generated the image for us really, really, really fast. So here we go. Here's our image. You see, very nice image here. Remember, this is a 512 by 1024. Not bad. And this was the so here is our model. Where can I see? It's hard to see here. Oh, there we go. It's on the top. Oh, because of this guy on the top. Okay, so that's it on the top. Let's see if I can squeeze this down just a little bit. There we go. Okay, so that's our image. As you can see, really nice. Remember, this is the Q4 quantized 4 model. Really nice, pretty. Okay, now let's do the video. Don't worry, for the video, it's going to be much simpler. So you see, got 8 gigs of stuff. That's why I said I want this tutorial to be done quickly so I can. Okay, so let me actually put this here just for now. All right, next we're going to do the video one. Okay, so I'm going to use nano again. This is going to be 1. So as you can see here, again, we import torch, diffusers, import the autoencoder, WAN pipeline, and the diffusers. And the diffusers, remember, we installed those. And then export to video. For this one here, this is why we need the FFmpeg library. And then it says here the model path. So this is the thing that also confused me. You just put the path to that actual folder. As you can see, I put it here already. And then the VAE, again, I was actually able to produce something using some combination. I think this one, the VAE must always be, yeah, so here we go. See, this is float 16, unlike the other one where I had to use B floats. So this one, float 16, I'm able to use it. And here also float 16 for the, what's this one for? Oh yeah, so this is for the model, and this is for the VAE, and then the text encoders. I'll just go to the, okay, it looks like I have to, where is the cursor? It's hard to see where the cursor is. Oh, here it is. The cursor is down here. So you guys can see. And then again, pipe to CUDA. And then, I removed there was a part where they had the CPU offloading, so I didn't want to do it. I took it out. Now, if you don't have, I said, the GPU power, yeah, do make sure you actually put the CPU offloading. I don't want the CPU offloading, that's why I removed that option. And it just says a cat walks on the grass, realistic. Remember, this is a very small model, and then you see I also put a negative prompt. By the way, the Z image turbo doesn't have a negative prompt. That's why you just have to put your prompt there immediately. So you see here, the negative prompt is bright tones, overexposed, static, blurred details, subtitles, style, works, paintings, images. What else is here? Static, overall gray, worst quality, low quality, JPEG, compression residue, ugly, incomplete, extra fingers, poorly drawn. I'll just read all of them out here. Where am I here? Poorly drawn hands, poorly drawn faces, deformed, disfigured, misshaped limbs, fused fingers, still photo, still picture, messy background, 3 legs, many people in the background walking backwards. So that's the negative prompt. Very, very specific. And then here I'll show you the output, obviously the prompt, the negative prompt as well, negative underscore prompt. The height is 288, the width is 480, the number of frames is 33, inference steps is 20, and then the guidance scale is set to 5. You can put a little bit bigger as well, but it's perfectly fine. And then it's going to output as a MP4 with FPS of 15. So I'm going to exit out of here, and then we're going to run this one again, just simply Python when, and run this. So don't worry, this one is not going to download like 27 gigs of stuff. This one is going to be fast because it's the stuff is already downloaded. If you remember, I showed you guys the folder earlier. So I'm going to put this here so you can see what's going on. Oh, what is going on here? Oops, it's the memory. I don't want to see the memory. The memory, actually, this, you guys only see the network, and what's the other one? The disk. But you need to see the memory and the CPU. There we go. That's all you need to see. I can't remember how long it took because I'm only doing one run. And you can see it's loading immediately, and it's loading the weights. It's at 25%. Audio is working. Yeah. So remember I was telling you about the Z Image Turbo. Get some really good results, as you can see here. The Q4 model, it's really pretty impressive. Let me actually zoom in here. See, obviously it's pixelated there, but it's pretty good. It's obvious. I know this is only 512 by 1024. It does really well with human. It also de-ages people. What I'm saying is, for me, like say my claymation characters, I don't need them to be de-aged. So, but I'll find some. I also tested the Flux One Dev Snijo. Okay, so it's loaded the stuff. I'm wondering how many steps do we put? I think 5 steps. So as you can see here, despite me telling it to you see, it still likes to load the stuff into RAM for some reason. That always drives me crazy. It's like what's the point of having the GPU then if it's gonna load everything into RAM first before it passes the GPU? So that's the part that always drives me crazy. Okay, so some spam here. Okay, perfect. I got that one. On Twitch, I got some spam stuff. I don't know if you guys will show up. So, oh, it's 20 steps. I forgot the inference steps was 20, so it's 20 steps. You can see it ramped up the RPMs of the dedicated GPU. Alright, we'll let that continue. In the meantime, I'll see what's going on here. I don't remember what I was doing. Come on, where's my mouse? Oh, this glare. I see why people complain about laptops which are glossy. My goodness, I can't see anything here. Okay, there we are. I was hoping to take this laptop outside when I let the chickens out during the spring and summer, but that's not gonna happen. The glossy screen is too much. Oh, I wonder if I get I should order some sunglasses maybe. That would be cool. Wear my sunglasses outside and actually do some. Maybe I'll do that. So these glasses are just replacement glasses for my other one until Once I get the car working, I'll go back in town, get my prescription, order proper glasses. But this one's actually, as a temporary, it should be fine. Oh, by the way, I have I'll tell you guys another funny story. I have a 2008 Sebring. So you know where the battery is? Yes, you heard right. It's in the wheel well. It's meaning that you gotta take off the passenger side tire. You literally have to take it off in order to replace the battery. Sheesh. No wonder the mechanic put a battery that lasted 8 years. It's a pain to do that, right? All right. So the video has been created. Oh, it actually looks pretty good, I think. So let's go check it out. It doesn't tell me how much time it took. Oh, I should have timed that. Sorry, I apologize. I forgot to time it. I don't know how long that took. I guess if you're watching the video, you can place the time. Where's my mouse? Oh, here we go. So here we go. We have this guy here. So let's see what it looks like. Remember, this is only 480 by 288 or something. Yeah, 480 by 288. Let's see what the video looks like. Okay, that's a little bit too big. Actually, that's the best video yet. Why does it open up in full screen? Where's my mouse? What's the problem with this glare? Okay, there we go. Way down here. Wow, that actually came out really good. I'm actually surprised. That came out really, really, really good. I'm really surprised. I'm really surprised it came out really good. It was cartoonish before all my runs, and then obviously when I do the live stream, it actually comes out even better than anything. Wow, that's impressive. Or maybe because I was experimenting with so many different things until I got it right, and wow, that's actually very nice. I like the grass and all of that. Yeah, so that's, yes, obviously, there we go. And I think 2.5 seconds the video is. It says 2 seconds, but remember it was 33 frames, and I think it's 15 frames per second. Yeah, so 2 seconds, just over 2 seconds. So there we go. I wanted to show that to you. And it came out really good. I could actually even upscale that if I wanted. So, ta-da! So that's how you run. You can run Python. You see, we didn't have to use any libraries like conf.ui, any of the stable-diffusion, any stuff. We just did everything right on the command line, and we finished. Now, well, the that noise you're hearing, it's the RPMs are going down for the fan. Oh, it went down pretty quickly. That's one of the good things about winter. Alright, so while this is here, I'm going to show you guys how to, if you remember, let me put both of them here in case people are on a vertical screen and I want to see it again. So this is our Z image turbo. And, oh, why did I close that? Maybe I wasn't smart. There we go. And this was our video that we generated using conf.ui, not conf.ui, only Python. So both of these were just generated using Python. Okay, so what I'm going to do is, I kind of like both of these. So I'm going to, okay, so I'll show you how to remove stuff, because people don't show you that. They just show you how to install stuff, then we'll show you how to remove. So I'm going to show you how to remove all of this stuff. So first thing you do, you just let's clear this. You see, I'm still in the Python environment, so just deactivate. So you deactivate it. So we have deactivated. Now everything that was installed into this folder. So if I type ls, it was installed into this AI environment folder. So let's see how big that file is. dushai. You see, it's actually pretty small. It only takes up 207 megs, because remember, the biggest libraries, those ones I said I installed it system-wide. You see how small that is? That means I can actually leave this if I wanted to. However, we know better than that. So I'm going to get out of this folder. I'll delete it later. Get out of this folder. So the thing that I'm more interested in is, if you remember, we have a couple of things that are annoying. This one, 2.1 2.1 text to video 1.3b is huge. So for example, if I type du space -sh, and I'll show you how big it is. If I just type 1, you see it's taking up 27 gigs. That is massive. I don't need it anymore, so I'm just going to remove it, because I want that. So I've removed it, and now if I type df, you see now my AI folder. Now I have 46 gigs to play with. Whew, thank goodness. All right, but remember, we also have a Hugging Face. Hugging Face stuff is stored here as well. Where is Hugging Face? Why can't I see? Hugging Face here. Hugging Face is also pretty big now because it got about 8 gigs. You know that you saw that 8 gig of stuff you downloaded for the Z Image Turbo. That stuff all went into the Hugging Face. So I want to get rid of that as well. So if I type, let's see how big Hugging Face is. You see it's 7 gigs. So it did do some compression. So let me actually go and see how big that, let's see if we can actually figure out. If you ever wondered how the Hugging Face photo looks like, you see you have hub, and then you have Z here. So you can also do a tree if you want. So I'll show you tree, Hugging Face. You see there's a bunch of stuff here, there's a log, and there's a whole bunch of stuff here. So I do need some of the stuff in here. And you see models. So this model here's a Z Image Turbo. So there's a, I think there's that model, and there's another one I'm using for something else. You see it has the VAE transformers and all this stuff. I'm also doing, I think I can just remove it, tokenizers, the models. Is this all for the Z? I hope it is. Let me see. Snapshot. Yes. Okay. So I can remove. I can just remove that, and everything else should be fine. So I believe this models or whatever in the hub here. If I remove that, I should be perfectly fine. This is just a log. So there's nothing here. Yeah. So I'm gonna. That's the only model I have. It looks like. So I'm gonna wipe that one out. I'm gonna wipe out this model. I can also get rid of the blobs. Yeah, but I'm just gonna remove that. All right, just now. I was gonna say I'm a professional, which I am really. So I'm gonna copy that, and I'm just gonna delete it. Now I can do that because I'm not gonna do this again. So I'll just go remove. If I can also simply just go into the, I think it was in the hub. I can simply go to hub and just delete this as well. I could do that as well. But hey, we're doing command line stuff here, so might as well. Go to hub. It won't harm anything because I'm not going to use it anywhere else. Hub. Oops. It's Hugging Face hub slash. I think I just start typing a name. What is the name again? Models. Yeah, there we go. It's now that folder is empty, it doesn't exist anymore, and that's exactly what we want. Now, if I run that command again, you see it's only 14 megabytes. Okay, so I'm very happy with that. That stuff is gone. Now, if I go back to the df h, oops, what did I do here? df with an h. You see, now I have 54 gigs of available space for my what do you call this? For AI stuff, and obviously Podman and all that stuff as well. So I'm pretty happy with that. This one is next, and I think in 2-3 days I'll be able to recover some space from this one as well. But just for you guys, I have to keep it a little bit longer, but I'll be fine. Now I can breathe some sign of relief and have some space to do other AI stuff. So there we go. And we still have our generated Z Image Turbo, and we have our video here. That is really, really, really nice. Really nice. Look at that. Cutie cat. I'm not a cat person, but man, that came out really good. That is probably one of the best quality stuff I've seen from the 2.1, 1.3b. And I've been, man, I've tried FP16, all that stuff. Just couldn't get a good quality. And the funny thing is, I wasn't expecting much today, and boom, we get a pretty good quality. So that's it. That's it right there. All right, and so the problem is you need space, not just RAM. You need storage space as well. So people will tell you, oh, all you need is a big GPU. No, you need RAM, and you need storage space to run this AI stuff. Just be warned. Okay, so let's finish up this tutorial. I think I don't need this anymore. Yeah, I can probably just exit out of here. And you guys have seen my system enough. Okay, so let's finish this. You can master the professional stack. Master the professional stack by exploring these essential resources for your continued technical growth and career development. You can find comprehensive guides and advanced literature at ojambo.com and also my bookshop on Amazon. I'll show you that a little bit later, but you can search for Edward Ojambo on Amazon, or you can simply click on the link. The links are in the description. I also offer blueprints now on ojamboshop.com. I haven't officially done the pivot. I mean, it is ongoing, but you can check it out. That's ojamboshop.com. And after that, if you need one-on-one tutorials, you can contact me on ojambo.com/contact, or if you need consultations at ojamboservices.com/contact. These tools represent the future of independent media production and high-level computation creativity in the modern era. By mastering the command line, you position yourself at the absolute forefront of the generative AI intelligence revolution. Start building a local environment today and reclaim your digital freedom from the limitations of the cloud. Your hardware was designed for greatness, so it's time to let it perform at its maximum capacity. I do agree with that. I also have some other resources. For example, I have this my novelette. I have a copy right here. It's a novel, Algorithmic Serpent. It's by me. You see my name there, Edward Ojambo, and it's about an AI scientist who creates an AI system and loses his mind, so he has to regain control of his mind and the AI system. It's a psychological thriller. I say it's just a novelette. It's a paperback version. I'll talk about the ebook version in a second. So this one is mostly at cost, meaning that the majority of costs are for printing and shipping, obviously the paperback version, and for storage costs for the ebook version. My greatest one is the Recession Business Blueprint. That's a guide to help you start a business during a recession, so you can, whether it's a side gig, whether you want it to be a full-time job, it could be a service, it could be a good, or something in between. It could be business to business or business straight to consumer. That's all up to you. This guide will help you in your endeavor. So whether you need training, you have to decide whether, for example, when I started my business, I wasn't comfortable with my marketing skills, so I went back to school. I actually took a diploma. It's called business management. All I cared about was the marketing part. And then everything else I knew. I knew how to do accounting. I need the law because I do, as you guys know, I'm pretty averse with licenses and stuff. So I'm saying I know the law very, very well, especially software licenses. But I said the thing I lacked was the marketing. I wasn't comfortable with my marketing skills. So all that information is in the Business Recession Blueprint. As I said before, it's a full book. You have over 100, I think, and 20 or 30 pages. That's already excluding the I said, like the other stuff like table of contents, appendix, all that kind of stuff. So, and then if you have any questions, you can contact me. I'll show you that in a few minutes. Here's my bio. I'm a software engineer. I'm also an author, and you can visit my book page on Amazon. The link in the description. If you need support, ojamboservices.com. And if you want to learn how to build yourself, I said the blueprints at ojamboshop.com. It's pivoting from courses to you're going to have free. You'll be able to download free blueprints for like backyard structures, small living, and woodworking. Okay, here's a comment form. The comment form stays up 14 days after the article goes live. You can post anything about today's topic. We talked about Python, talked about generative AI, images, video, the 1.2.1, 1.2.2. We talked about the image turbo, another type of models. That's perfectly fine for the comment section. If I did something wrong, or there's a faster way to do this, especially if you're an AMD, let me know. Sure, and share with everyone. Remember I said we're here to share. Okay, and the best way to contact me is to use the contact form on jambo.com/contact or jamboservice.com/contact or jamboshop.com/contact. And then if you want to follow me, you can follow me on these channels: Odyssey, Rumble, BitChute, YouTube, Kick, and Twitch. By the way, I'm live streaming onto them, all 6 of them at the same time right now. Okay, again from the command line, just using FFmpeg. Okay, now what I'm going to do is I'm also going to implore you to subscribe, like, follow, and leave comments, because as I said before, the more people subscribe, the more this content gets pushed out to more viewers. Those viewers join this growing community. They can post their tips and tricks, they can post requests or anything in between, and I'll personally research and I'll share with everyone. So this was something I've always been interested in, and I said, that's why I said I shared with all of you guys. Now you guys can go and do the same thing. Whether you have Vulkan, whether you have CUDA, NVIDIA, or I think it's called One API by Intel, or some other in between, you don't have to. And I said, and also the thing I showed you today to get away is that you don't need to have a whole bunch of Python environments with different. You can share everything, as you say. Everything shares system wide for less resources in terms of RAM and disk space. I gave you a workaround for that as well. So you got a lot of, you got your money's worth in today's tutorial. Okay, now I'm going to go to the outro. I'm going to scroll up a little bit, and where should I end? Right here, it's good. So, here's part. If you want to see what's upcoming, you simply go to jambo.com, you go to the watch menu, and then lifestyle menu. You see I've just finished this the Python command line secret for local image and video generation. Then tomorrow we're going to use our Raspberry Pi 0, which I do have a copy of right here. I mean, we have one, it's on here. So I'll show you how you can install, you can wireless multi-room audio mastery on our Raspberry Pi. Then after that, we're going to review this game engine that's inside Blender. I'm sorry, it's installed and meant to work inside Blender. I'm careful the way I word that. So it's called Armory 3D. And then the day after that, we're going to review a streaming, I guess, platform, self-hosted streaming engine. It's called Restreamer, I believe it's called Restreamer. And then after that, we're gonna do my AMD Instinct MI60. We're gonna test it as a game, I guess, what do you call it? For gaming. We're gonna test its gaming performance. Okay, yes, you heard me right. Yeah, we're gonna test its gaming performance, and so that's gonna be more of a podcast-like thing. So hope you can join for that as well. And again, shout out to the Tech Rants and everybody joining today from wherever whether it's Apple Podcast, Spotify, I think Apple Music, Amazon Music, Google. I think it's called Google Play or Google Music. I think it's called, no, Android Music. I don't know what it is. Yeah, Google keeps on changing names. So welcome. All right. So with that said, I am going to the live chat. I don't see any more live chats. Thanks everybody joining the live chat today, and obviously live stream. And be sure to like as well and leave comments if you can. Thank you very much, and I'll see you guys tomorrow at 2 p.m. Eastern. Bye now.